Hi, I'm Kung. You might know me from my development work on OpenVR advanced settings or some of my YouTube tutorials. In 2018, I made a full-body avatar tweaks tutorial for VRChat. Well, here we are in the future. It's 2020 and about time for an update. Full body in VRChat changed in September 2019, and I've included tweaks for the new system. With a tutorial like this, you're probably looking for one of two things. Either you're already experienced and just want information fast, or you're new to this and want a full walkthrough. To satisfy both, I'll first show a fast visual guide. For the experienced, it'll quickly show you what to do. For newer people, think of it as a preview for the walkthrough that's after. Okay, here's the visual guide. Okay, some of that was really fast. If you want to watch it again, I'll put a timestamp in the description. But if it was way too fast, next up is the full walkthrough. First, let's talk about fixing proportions. In order to do that, though, we need to talk about the user real height setting. User real height in your VRChat settings menu is a value that simultaneously controls two different things: world scale and vertical position. The goal of the setting is to be a single-step process to help fit any avatar to your body. It does this by scaling everything to match the length of your avatar's arms to your real arms, and then moving everything up or down to match your avatar's eyes, or specifically the view position you set in Unity, matching it up with where your real-life standing height should be. So despite the setting's name, the overall scale is actually set based on arm length. The avatar's height, or in other words how far down the floor is, will just end up wherever it has to once it's shifted so that your avatar's view position matches your standing height. It's useful to understand this intuitively, so let's take a look at what happens when we change stuff. If you increase the user real height value, it'll assume you're bigger, and scale the whole world bigger to match your assumed larger body. It'll then vertically shift the world up, so that the avatar's view position targets the higher value you set up there. Whether the effect of the larger scale makes the floor go down, or the effect of the world shifting up makes the floor come up, depends on the arms to height ratio of your avatar, and might make the floor shift seem unpredictable. It's easier to think about the more predictable shift in the view target to match the height you set. If you do the opposite and decrease the user real height value, it'll assume you're smaller and scale the world to be smaller. Then vertically shift the world down so that the avatar's view position targets the lower height value you set. But why even do this? Why not scale for height instead? It's to avoid this. If your height scale is wrong, it only feels bad from your own perspective. If your arm scale is wrong, it looks bad to everyone. A problem we're going to deal with, though, is that the game is extra careful to avoid glitchy held objects, and it defaults to scaling the avatar's arms to have a little bit of extra length. For a simple one-click setting, it makes sense, but unless your real arms are proportionally very long, we're gonna need to lie about our user real height to get a custom fit for our avatar. This comes with the minor inconvenience that once we lie about our height, the game's automatic vertical shift is gonna target our fake height value. Fortunately, that's a simple thing to fix with OpenVR Advanced settings, and I'll show you how to do that later in the video. Alright, so assuming we compensate for the height offset using OpenVR Advanced settings, now we can think of user real height simply as arm length scale. We can now take a simpler look at how the setting changes things. If we increase user real height, our avatar gets bigger. If we decrease it, our avatar gets smaller. But if instead we actually change our avatar itself and start scaling the arms, which we'll need to do later, this is how that works. If we make our avatar's arms longer, everything will get smaller to fit back in. If we make our avatar's arms shorter, everything will get bigger to compensate. Overall, user real height is our control knob for scale, but it's also kind of reset every time we mess with our avatar's arms, so it's important to understand for full body avatar tweaking. Okay, now that you're an expert on user real height, we can start messing with our avatar's proportions. First, we're going to need a reference image that shows the trackers on our body on top of our avatar, with the avatar set to the correct scale so its torso matches us. That way, we only need to scale the legs and arms and everything else will match. For that, we'll need a mirror. Okay, now that I have a mirror and a camera ready, I need to adjust the scale of my avatar to match my real body. To do that, I'm going to open the Calibrate menu, and put my controller on my shoulder, and my other controller down here. I can see that my avatar's torso is smaller than my real torso, so I need to adjust my avatar to be larger. I'll use the user real height setting to make it larger. Increasing the user real height made my avatar larger, but let's open the Calibrate menu so I can see my controllers again. I can see now when I put my controller on my shoulder that there is a vertical offset, and I need to use OpenVR Advanced settings to fix this. If you don't have it installed already, there's a link in the video description to download OpenVR Advanced settings. Once you have it installed, go into the Motion tab and enable Space Drag on whichever hand you intend to use. If you want to, in the Offsets tab, you can enable Lock X and Lock Z to prevent yourself from sliding side to side when you make your adjustments. If you don't have a binding set for Space Drag, you can go into the Bindings menu here and assign a button. Now that Advanced Settings is set up, I can grab space and climb around freely. I'm going to line up my avatar's shoulders with my real shoulders again. Now I can check that my avatar's torso is roughly the same size as my real body. I want to make sure that my trackers are visible, put my controllers inside the avatar's arms, and hit the timer on the camera. Now I can take a screenshot for using in Blender. Alright, we've got our model open in Blender, and we're ready to start scaling to fix the proportions. But before we do that, there are a couple of precautions we might want to take to prevent issues where the mesh kind of tears up into little holes when we scale. The first of those is going in the CATS plugin and joining your meshes. This is particularly helpful when you have different meshes that are part of the same skin on the surface of the body. When you scale, a little hole can open up between those meshes, so it's a good idea to join your meshes. Next, we're going to want to go into Edit mode on the body and do what used to be called Remove Doubles, but in Blender 2.8 is called Merge by Distance. First of all, it might be a good idea to deselect your head to try to prevent issues with shape keys later on. Press numpad 1 to view from front on, then press Alt-Z to go into X-ray mode. Press B to open a box selection tool, and hold Shift and drag a box to deselect your head. Now we can press Alt-Z again to exit X-ray mode. Press F3 and type in Merge, and choose Merge by Distance. Next, we're going to want to select the Data tab on our body mesh and check to make sure that our shape keys didn't get messed up. Just select one of the shape keys and drag on the value slider to make sure it looks okay. Because we changed the number of vertices on our mesh, there's a chance that our shape keys could have gotten messed up, so it's just a good idea to check every time you mess with the number of vertices you have. Make sure to reselect your basis shape key after you're done. A common issue is doing edit mode while you're in one of your shape keys rather than the basis. This can really mess up your shape keys later, so make sure you're back in the basis shape key. Okay, Back in the CATS plugin, click on Start Pose Mode so that we can start to mess with the proportions on our model. There are two different ways that you can scale the bones. You can use the global coordinates or local coordinates. Right now our model is in A pose, so we would have to use the local coordinates if we wanted to scale the length of the arms. I actually recommend putting the model in T pose to prevent an issue with the sagging shoulders. So let's look at how to put the model in T pose now. First, zoom into your shoulder bone and press Alt-B to make a selection box that will hide everything outside of the box. Now let's look at the shoulder bone from side on by pressing numpad 3. Select the bone and zoom in. We're going to press R and Y to rotate around the Y-axis, and line up the head and tail of the bone so the bone is pointing straight at the camera. There we go. Let's press Alt-B again to unhide the selection box. Now to straighten the arm, select the arm, press Alt-B again to make a new selection box around the arm, numpad 3 to view from the side, R and Y to rotate around the Y-axis, and again line up the head and tail of the bone. That looks pretty good. Let's press Alt-B again to unhide that selection box. Now we want to copy these values to the other side of the body. That's really easy to do. Just click the selection tool, select your shoulder, and hold Shift and select your arm. These are the two bones that we just modified. Press Ctrl-C to copy the rotation values, and Ctrl-Shift-V to paste it on the other side of the body. There we go. Now we're ready to scale the arm to the proper length. Looking at our reference screenshot, press numpad 1 to look flat on from the front, and choose the Cursor tool. Now let's put the cursor roughly where the controller was in our reference screenshot. About here looks right. Click on the selection box again so we don't keep moving the cursor around. And one thing you might want to make sure of is that we disable Inherit Scale from our wrist bone. So click on the wrist bone, go down into this little bone menu here, find Inherit Scale, and set it to None. If we want to scale both the upper arm and lower arm together, then we will want Inherit Scale on the lower arm. Okay, now click on your upper arm, press numpad 1 again so we can view it from the front, and press S and X to scale along the X-axis. Let's line up our arm so it roughly looks like the hand is holding where the controller should be, as marked by the cursor we set. That looks pretty good. Before we copy and paste this to the other side, we have to be careful that the bone inheriting settings are the same over there. So let's click on the wrist bone and make sure that Inherit Scale is set off over there too. Okay, now we can select the upper arm, press Ctrl-C and Ctrl-Shift-V to paste its settings over to the other side. One thing to note is that we were scaling along the global axis, so if our arms weren't roughly straight, they could have gotten squished or skewed in a weird way because we were scaling diagonally to the direction of the arms. The arms are roughly straight on this model with a very slight bend back in the elbow, which is necessary to prevent the arms from flipping around once you get in game. But when I do the legs, I'll show you how to scale along the local axis to prevent weird skewing of the bones. So let's do that now. Select the cursor tool, press numpad 1, and click the cursor roughly into place where we see it in our reference screenshot. As before, we want to disable Inherit Scale and Inherit Rotation on our feet. So click on your foot, and under the Bone tab, disable Inherit Scale and also Inherit Rotation. This will keep our feet level with the ground. Let's do this for both feet. Let's press numpad 1 to view from front on, click on the thigh, and press S to scale and Z to lock it to the Z-axis. We're scaling along the global axis right now, but we're just doing that to see roughly how much we'll have to scale the leg. Line it up with your cursor, keeping in mind that your tracker is probably mounted on top of your foot, not inside of it. Let's line up the foot slightly under the tracker's location. Take a note of the Z value here. It looks like it's about 0.7. Now press Ctrl-Z to undo that scale. To do it individually, we'll need to click off Inherit Scale on our lower legs. So let's disable Inherit Scale now. Make sure to do it on both sides. Now at the top, change the transform orientation from global into local. Select your Scale tool on the left side, and scale the thigh. This time, because it's the local axis, we're scaling along the Y-axis. Let's type in the value from before, 0.7. Now select the lower leg, and again, grab the scaling tool and scale along that axis. Type in the same value, 0.7, and we can see that our leg again lines up with where our tracker position should be, but this time we scaled along the direction of the bones instead of the global z-axis. Another useful thing to note here is that you can scale the thigh and the lower leg by different amounts so that your knee will end up in a different position if you find out that when you get in VR, your knee feels like it's in the wrong place. Okay, because we scaled the thigh and lower leg, let's shift select both of them, press Ctrl C, and Ctrl Shift V to paste those values to the other side. Now that we've shortened the legs, we could be done, but because we only reduced their size vertically and did nothing to the width or depth, they could be ending up thicker than they started. If the legs look too thick to you, you can slightly reduce the width and depth using the scale tools. Let's do that now. To help get a better view of one of the legs while we scale it, we can use that Alt-B selection tool to hide everything else. Press Alt-B again to show everything again. And now that we've adjusted the thickness of our leg, we can copy these settings to the other side, just like before. Hold Shift and select the two bones that we modified, press Ctrl C, and Ctrl Shift V to paste those values on the other side. Make sure that when you're copying bone transforms to the other side of your armature, that the settings for inherit scale and rotation, etc. are all the same on the other side. If they're not the same, when you paste the values over there, your armature will end up asymmetrical. Just as our legs ended up a little bit too thick, our feet and hands might also be slightly too large because we disabled inherit scale when we scaled the arms. Turning off inherit scale was important so they didn't get flattened along with the shorter legs, but they might end up being too large. If you want to fix that, you can select it and press S to scale equally along X, Y, and Z, but I recommend to actually hold off on that and wait until you've finalized your avatar's scale and uploaded it into VRChat. Once you're in VR, you can really get a good sense for if your hands and feet are the correct scale or not. It's kind of hard to eyeball this in Blender, but when you're in VR and looking at your own hands, it's really easy to see if it's off or if it's right. Okay, now that we're finished adjusting our proportions, we can go into the Cats plugin and click the Apply as Rest Pose button. And now we're almost done, but notice that our avatar is floating above the origin point. To get our avatar back on the ground, we need to select the very bottom of the mesh. On the body mesh, go back into edit mode and find a very low vertex to select along the bottom of the mesh. I'm going to press numpad 3 so I can view from the side, and select a single vertex on the very bottom of my foot. Now press F3 and type in cursor, and choose Snap Cursor to select it. Now our 3D cursor is lined up with that vertex, but we only want the height value, so under your View tab, under 3D cursor, drag across X and Y and type in 0. Now our 3D cursor is centered along the front and side, but lined up with the bottom of our mesh. Now let's go back into object mode and select our body mesh. Press F3 and type in origin. And choose Set Origin. Choose Origin to 3D cursor. Still in object mode on our body mesh, under the Item tab, look at the transform location. We can see that now there's a value on the Z-axis. This is how far it is above the global 0 point. We're going to need this value, so select it and press Ctrl C to copy it. Now, to get the body mesh back down to the global 0, type in 0 and press Enter. You can see that our body is lined up now, but the armature isn't. Because our armature is a hierarchy object which contains the body mesh inside, we can't use the same technique to get it down to the 0 point. Instead, select the armature, go into edit mode, and press A to select all. Press G to grab, and press Z to lock it to the Z-axis. Now move it down slightly. This is where we're going to need the value we copied from before. Being careful to keep the minus sign at the front, paste in the value from before, and press Enter. Now our armature should line up with our body and everything should be nicely at ground level. We're now finally ready to export our model back into Unity. Here we are in our old Unity project. If you're just going to upload this as a new avatar, then you can just use the normal process for that. But if you wanted to keep everything you set up in your scene view, you'd have to overwrite your old avatar. So I'm going to show you how to do that and some of the things you have to be careful about. First of all, you need to browse to your Unity Assets folder and find the model that you're going to replace. Make sure that the new fixed version has exactly the same file name, and then in your Unity Assets folder, delete the old version. And copy and paste the new version in its place. When you click on Unity again, it will import the new version. You can see that it's changed in the scene view now, but our humanoid rig configuration actually hasn't been updated yet, so we need to do that now. To flesh out our old rig configuration, click on your model file. In the inspector, go over and click on Rig, and under Animation Type, change Humanoid to None, and click Apply. After it's been applied, click on Humanoid once more, and apply that again. This has refreshed our humanoid rig with our new proportions. But along with that, it threw out any previous configuration to your humanoid rig. So let's click the Configure button and make sure everything looks like it should. Click on the Head button and make sure that your neck is mapped. If you need to map a bone, click on this little dot on the right and type in the name of the bone, and then select it. You might want to unmap your jaw. To unmap a bone, click on this big circle and press Delete. Personally, I use an animation instead of eye tracking, so I also leave my eyes unmapped. Once everything is how you like it in your humanoid rig configuration, click Apply. Then click Done. A quick side note about overriding your model. Sometimes when you re-import, your dynamic bones might end up messed up something like this. If that happens, you will need to fix it individually for each dynamic bone. First, find the dynamic bone script causing the trouble in the hierarchy. On the dynamic bone script, click the small gear icon on the top right and choose Copy Component. Then click the gear icon again and choose Remove Component. Under each bone transform that was affected by the dynamic bone, you'll need to click the little gear icon and choose Revert to Prefab. After you've fixed all the dynamic bones, go back to where your dynamic bone script was, click the little gear icon and choose Paste Component as New. You'll have to do this for each instance of a dynamic bone script you have on your avatar, but if you find yourself with this issue, this is a way you can fix it. Okay, back in the scene view, select your avatar, and notice that the VRC Avatar Descriptor's view position doesn't match your avatar anymore. There's two ways to go about fixing this. The easiest way is just to adjust the Y value so that the view ball matches your new eye height. However, this would make your avatar relatively shorter compared to other people when you log in next time. If you want your avatar to stay as tall as it's always been, instead, you can adjust your avatar's scale to match the old view height. First, for a flat view, click the cube in the top right, and click the cones until you're viewing front on. Position your view ball right at the edge of the top of the screen. Then, with your avatar selected in the inspector, go under Transform, Scale, and change the Y value until your eyes also match up with the edge of the screen. Now that you know the scale factor, copy and paste it into the X and Z values as well. If you want things to be as close as possible to the way they were before, under your VRC Avatar Descriptor's view position, multiply the Z value by this scale factor as well. So either way, whether you adjusted your view ball position down or you scaled your avatar up, once the view position matches your eye height, you're ready to upload your avatar back into VRChat. Now that I've uploaded the avatar back into VRChat, I need to change the user real height setting again, because I changed the length of the arms in Blender. I can see that when I fully extend my real arms, I can't reach far enough to make the avatar extend all the way. That's because the avatar is too big, so to make it smaller, I'll reduce the user real height setting. Still not quite small enough. And that looks about right. When I fully extend my arms, the avatar's arms also extend. When I slightly bend my elbows, the avatar's elbows begin to bend too. But As you can see, if I open up the calibration menu, my height is offset again. So I'll use OpenVR Advanced Settings to drag my shoulders back into line. This is a good chance to check if your torso is still correctly scaled. It looks pretty good. And now I can bind in. At this point, if everything's looking good, you're good to go. You might need to repeat the process with taking more screenshots though, if it isn't. One thing you might notice though, if I press Reset in OpenVR Advanced Settings, my position shifts. This is because when I bind it in, I had an offset in the Offsets tab. When I correct my position with calibration, I end up with an offset here. If I want to save this as the reset point, that's actually really easy. Just go into the SpaceFix tab and choose Apply Space Settings Offsets as Center. Now my offsets are set back to 0, but I'm in the correct position. Now I can bind in, drag around, and reset myself back to the normal floor level. When you're doing this, you want to make sure that you only had an offset on the y-axis, no rotation or x or z. Otherwise, you'll apply that slide or rotation into your 0 point that you reset back to. And with that, you should be good to go with your fully proportional avatar, as well as having the freedom to climb around using OpenVR Advanced Settings. One final thing, now that you've completely finalized your scale, you might notice that when you get into VR, your hands or feet might feel like they're the wrong scale. If you're not going to keep changing the overall scale of your avatar anymore, now's the time to go into Blender and adjust the scale of your hands or feet so they feel right in VR. Alright, next up we're going to look at some other common issues with full body rigs.
Alright, this next one is really simple. If your avatar ends up looking like this, with the shoulder sort of separating away from the body, it's probably because your hip bone is directly on the straight line formed between the bases of your thigh bones. I'll press numpad 1 and zoom in so you can see this from the front. You can see that the hip bone is exactly the same height as the root of the thighs. It's even clearer when I press numpad 3 to view from the side. Here you can see it's exactly the same height as the root of the thighs. The fix for this is really simple. Click to select your armature, and press Tab to go into Edit mode. Select the base of your hip bone, or what Blender calls the head of the bone. Press numpad 3 to view from the side. Press G to grab, and Z to lock along the Z axis, and move the hip bone up. And that's it. This should fix that broken shoulder. You're now ready to save and export your model back into VRChat. I should note that the forward or backward position of the hip bone does actually matter, and it should be approximately above the root of the thighs. Otherwise, it could introduce a tilt into your hip when you bind in. I'll talk about that in the next fix. Okay, for this next issue, if your avatar looks like this with a hip tilted towards the back, it's probably because your hip bone is behind the root of your thighs like this. If you were to draw a line from the root of the thighs to the root of the hip bone, the angle it forms will dictate the tilt you get once you bind in-game. That means that if your hip bone was positioned like this, you'd end up with a tilt that looks something like this. So in order to fix this issue, you need to make that angle as close to straight up as you can. First, I'll go over the easiest way to fix this, which just involves changing the positions of the bones in the armature's edit mode. So let's get in edit mode, and first off, select the spine, click on this little bone icon, and make sure that it's connected to the hips, which is the parent. Then select the root of your hip bone and move it up a little. Doing this alone is going to help tilt up that angle to be more straight up and down. Then select the entire hip bone by clicking somewhere on the side, grab this little move arrow, and move it into position directly above the thighs. Technically, you might want it to be microscopically behind the root of the thighs, because that's the relative position in the T-pose reference that VRChat uses when you bind in. But this would only be a mathematical technicality, so it should look directly above.
And that should be good enough to export your model back into VRChat. But depending on the positioning of your bones, you might have had to drag stuff pretty far out of alignment from where it was weight painted for. Particularly the root of the spine might have gotten dragged around a lot. Next, I'll show you a method using pose mode, which doesn't move the root of the spine relative to its weight paints. Again, in edit mode on the armature, we're going to want to move the base of the hip up a little bit to help with that angling. We also do want to ensure that the spine is connected to the hip bone, as I showed before. Next, this time we're going to use pose mode. In the CATS plugin, click Start Pose Mode. Now, on the spine, under the little bone menu, click to disable inherit rotation. We need to do the same thing on the thighs, so under both thighs, click to disable inherit rotation. Now that we've isolated rotation to just the hips, we're free to rotate the bone and keep the spine and thighs in their original orientation. Our goal is to get the base of the spine directly above or microscopically behind the base of the thighs. To help with alignment, let's press Alt-B to make a selection box so we only see the parts we're interested in, and select the area between the root of the thighs and the root of the spine. Now press numpad 7 to view from directly above. Here we can easily see the alignment between the base of the spine and the base of the thighs. Press R to rotate and X to lock around the X-axis. And carefully rotate the hip bone so that its end, or in other words, the base of the spine, is very slightly behind the base of the thighs. It should look something like this. Left-click to apply, and press numpad 3 to view from the side. This looks about right. Press Alt-B to undo the masking selection. Zoom out and look at your overall pose. If this has given your avatar a very strange pose, you might have been better off using edit mode in the armature alone. But otherwise, let's continue with this method. In the CATS plugin, click Apply as Rest Pose. Because we just rotated the hip bone, it's no longer straight up and down. So let's use edit mode on the armature to fix that. Click to select the armature, press Tab to enter edit mode, and click on the side of the hip bone to select it. Under the item menu, under the tail of the bone, copy the Y value, and paste that into the Y value at the head of the bone. This will straighten out the hip again. And now we're almost done. One more thing we should check before we finish is the position of the feet relative to the floor height. Because we were swinging the legs around under the hips, they may have gotten lifted up or pushed down. So zoom in on your feet and check if they're properly at ground level. You can see that mine have a slight offset now because I was swinging the legs around. You will need to follow the process to reset the origin point that I discussed in the proportions editing part of this tutorial. Here's the timestamp for that. And once you've cleaned up the origin point, you're ready to export back into VRChat. Next, let's look at the issue where when you bind into your avatar, the entire thing shifts down like this. This is usually caused by having a chest bone that's too long. To fix this, we'll need to use edit mode on the armature. Click to select the armature and press Tab. This will be easiest if our bones are parented in connected mode. Click on your chest, and click on the little bone tab, and scroll down till you see connected, and click the checkbox. Repeat this process for the spine as well. Now we can click directly on any of the joints between the bones, and reposition them easily. Grab the arrow that shows up when you're using the Move tool, and move the base of the chest up. The joint should end up roughly around where you can imagine the bottom of the rib cage. Anytime you move the position of a joint, the further you move it, the more likely it will be that you'll need to touch up the weight paints. So, while it's necessary to shorten the chest bone for this fix, don't overdo it if possible. Somewhere around here should be pretty good. If your chest started out very long, it's likely that your spine and hip bones were also very low before. To avoid the possibility of weight painting touch-ups, you can leave them as they were, but I'd actually recommend that you raise them a little bit. In some cases, when the root of your spine is closer to the place where you wear your physical tracker on your body than the root of your hip is, it can cause the hips themselves to fall under inverse kinematics control in the game. This might not bother you or be very noticeable. If you were to notice it, it would feel like you don't have perfect one-to-one control over your hips. So although it's not absolutely necessary, I'd advise that you also reposition the root of your spine and hip such that the root of the hip is the closest to your tracker's location. To do this, click on the hip bone to select it, and drag it up. At this point, you should be good to go, but because we've changed some of the joint locations, We should check it out in pose mode to make sure that the mesh doesn't look too bad when it's deforming under the rotations. Click on the CATS plugin and click Start Pose Mode. Click around on the various bones in your spine chain and rotate them on all 3 axes, checking how the mesh looks when it deforms. If you notice any issues, this will need to be touched up with weight painting. Weight painting is beyond the scope of this video, but I've made another tutorial that I'll link in the description below. In any case, once you've fixed the length of the chest bone, you're ready to export your avatar back into VRChat. Sometimes, you'll find that your avatar's arms or legs seem all twisted up like this. Let's look at the reasons behind that and how to fix it. This problem is caused when the pull vectors, or the direction that the joints point at your knees or your elbows, are in the wrong direction. We're going to fix it mostly in pose mode, so in your CATS plugin, click on Start Pose Mode. In order to take better control over the rotation edits we're about to make, let's disable inherit rotation on a bunch of bones on the arms and legs. For the arms, let's disable inherit rotation on the wrist and lower arm. So click on the wrist bone, and under this little bone menu, find inherit rotation and uncheck the checkbox. Then click on the lower arm and do the same. Make sure you do this on both sides of the body. Click on the wrist, disable inherit rotation. Click on the lower arm and disable inherit rotation. For the legs, we're going to do basically the same thing. Disable inherit rotation on the feet and lower legs. So click on the foot and disable inherit rotation. Click on the shin or the lower leg and disable inherit rotation. Make sure to do this on both sides. Alright, now we're ready to start making our edits. First, let's fix the arms. We will be making our edits on only one side of the body and then copying the rotations over to the other side. Okay, to make sure that our elbow is pointed towards the back, first let's select our upper arm and then hide everything else with the Alt-B masking selection box. Press numpad 3 to view from the side, and zoom in. To start, we want the bone to be pointed directly at the camera, so let's press R and Z to rotate around the Z axis and line up the bone so it's pointed straight on. It may be possible that your bone was pointed up or down a little bit. In that case, press R and Y to align that. Now that the bone is pointed right at the camera, we want to give the elbow a very slight bend to the back, so press R and Z to rotate around the Z axis, and slightly move the end of the bone towards the back. As mentioned before, it can be a very minuscule bend. It's only the direction that matters. Something like this should be good. Now let's work on the lower arm. Press Alt-B to show the avatar again, and select the lower arm. Let's use the Alt-B selection masking box to hide everything else again. And again, press numpad 3 to view from the side. Let's repeat the same process to make the bone point straight at the camera. Press R and Z, and line it up as well as you can. If there's any vertical offset, press R and Y to line that up as well. This time we're on the other side of the elbow bend, so we want the bone to be pointing slightly forward. So to do that, press R and Z, and move the end of the bone slightly forward. Something like this should be good. Press Alt-B to show your avatar again, and look at the overall pose of the arm. Because we disabled inherit rotation on the hand, it shouldn't have been affected. If everything looks good, we can hold Shift and select both the upper and lower arm, and press Ctrl-C to copy the rotations, and Ctrl-Shift-V to paste it to the other side of the avatar. And now the arms are finished. If that was your only problem, you could apply the rest pose right now. But let's move on to fix the legs. First, let's make the thigh point straight down. Click to select the thigh, and press Alt-B to make a masking selection and hide everything else. Because the leg bones are pointing down, this time we're going to press Ctrl numpad 7 to view from below. And now let's start lining up the thigh bone. This time we need to line it up on the X and Y axis. So let's press R and X, and line it up on this axis as well as we can. Then press R and Y, and finish aligning it. And for the thigh bone, we're going to leave it pointed straight down like this. This is because it's recommendable for the thigh to point in the exact opposite direction of the hip. The hip bone needs to point straight up, so the thigh bone needs to point straight down. To get our desired knee bend direction, we're going to have the shin bone bend back. That'll make sure that the knee is bended forward. Press Alt-B to hide the masking selection, and select your shin bone. And press Alt-B again to hide everything but the shin bone. One more time, we're going to press Ctrl, numpad 7 to view from below. And to start out, we're going to align the shin to point straight down too. Again, aligning along the X and Y axis, first press R and X, line it up as well as you can, then R and Y and finish aligning it. Now the shin bone should be pointed roughly straight down as well. Let's hide the masking selection box by pressing Alt-B. Let's use Alt-B again, and this time hide everything except for the entire leg that we're working on. One more time, numpad 3 to view from the side. And now we are absolutely not finished yet. This is where some people get a common issue with their legs twisting up. Because the leg bones are basically straight, there's almost no way for us to know what the precise mathematical bend direction is. It could be to the back or to the center or to the front, we don't know. So I want to emphasize here that straight leg bones should not be the goal. Let's make sure that the knee bend is pointed forward by rotating the shin to the back. Press R and X to rotate around the X-axis, and rotate the shin back slightly. Press Alt-B to show your avatar again. And this should be a pretty good pose, giving the knee a definite forward bend. So let's copy the pose to the other side of the avatar, hold Shift and select both the upper and lower leg, press Ctrl-C, and Ctrl-Shift-V to copy the rotations to the other side of the avatar. And now we're done with pose mode. In the CATS plugin, click Apply as Rest Pose. And now we're almost done. There are a couple of final considerations to make. If you want to, you can select your armature, go into Edit mode, and press A to select all, and Alt-R to clear all the bone rotations. In my testing with an avatar with randomized bone rotations, I haven't been able to get it to mess anything up, but it's still recommendable to clear bone rotations before you export. And one final thing, you might want to look at your feet and check if it's still aligned with the origin point on the floor. Because we were swinging the legs around, we could have dragged the feet up or down a little bit. If you need to reset your origin point, there's a section on that earlier in the tutorial. And that's it, you're ready to export your fixed avatar. In this next fix, we're going to address a very slight sideways tilt of the hip that you might notice sometimes when you bind in. In my own testing, it seems that regardless of the tracker's physical position on your body, it consistently rotates downwards towards the right side of your hip. We can counteract this with a rig hack. By rig hack, I mean a rig configuration that's not officially supported, but it does get the job done. There's no guarantee that rig hacks will remain compatible with the game through future updates, so use them at your own risk. But moving on with this fix, to counteract the slight hip rotation, we're going to adjust the root position of our hip bone. Select your armature and press Tab to go into edit mode. Press numpad 1 to view from the front, and zoom in on your hip bone. Click to select the root of your hip bone. We want to drag it to the side as if it's being carried along by the rotation that we observe in-game. Viewed from the front of your avatar, this is a counterclockwise rotation, downward towards your right hip as viewed from first person. So in keeping with that direction of rotation, we're going to move the root of the bone towards the right slightly. You could think of this as giving the bone a rotational offset. To counteract the hip tilt, this sideways tilt of your hip bone should roughly equal the amount that you observe your hip tilting in-game when you bind in. You might need to upload a few iterations of your avatar to really hone in on the exact value that counteracts it for you. In my case, it was 0.0025 on the x-axis. As you can see, this is a very slight tilt. When you bind in-game, this offset hip will be pulled straight, and in doing so, apply a small rotation. Because we tilted the bone in Blender by the amount we originally observed the unwanted hip tilt in-game, when the bone is pulled straight, it should counteract that hip tilt. So for this fix, it's as simple as slightly offsetting the root of your hip to match the unwanted tilt that you saw in-game. And with that, you're ready to export your avatar back into the game. Next, I'll talk about another rig hack that I've come up with to address the issue where when you tilt your head like this, your avatar's shoulders flop around. This does have its own trade-offs, and just like the other rig hacks, use it at your own risk, but it does seem to get the job done. To conceptualize the issue, think about dragging around your body at the end of a stick that rotates at a certain point. The longer the stick, the more the body would be dragged side to side for any given rotation. So, to reduce the shoulder flap we might see in-game, we can lower the height of the VRC avatar descriptor's view position. We are free to do this assuming we're already making compensations using OpenVR Advanced settings to fix any height offset we might find in-game. As long as you line up your shoulders properly or look your avatar in the eye when you fix your offset, your view ball can be at a different height than your avatar's eyes, but you'll still look yourself in the eye when you look in the mirror. The trade-off with this rig hack, though, is that the more you misalign the height of your view ball, the more your view will actually slide out from the side of your eyes when you tilt your head down to the side. Though I should note in my own testing that putting the view ball slightly below my eyes actually gave me better tracking alignment when I tilted my head sideways. Also, humans will naturally flop their shoulders from side to side when they tilt their head, so I don't recommend trying to absolutely eliminate the shoulder flop, but rather to reduce it to a natural-looking level. So this fix is very simple, but for completeness, here's the walkthrough. In the Unity hierarchy, select your avatar. Under your VRC avatar descriptor's view position, reduce the Y value. The more you reduce it, the less shoulder flop you'll observe in-game. Here are some examples of different heights and the corresponding floppiness of the shoulders. Personally, I struck a balance with it right at the tip of my nose. It seemed to give a natural amount of sideways motion on my shoulders, while still minimizing the downsides. Since this edit is really easy, I'd recommend playing with a variety of values and finding what's best for you. So once you've adjusted the Y value of your view position, upload the avatar and test it in-game. In this fix, we're going to look at how to improve the appearance of your mesh under a certain pose, namely when you lay down on your side and move your head around. When you do that, it's sometimes possible for your neck to take on a zigzag appearance, like this. To fix this, we're going to try to reduce the neck bone's influence on the mesh. Although the methods are very similar to my old neck fix, this technique is addressing a different issue, and so the goals are a little bit different too. In this version of the neck fix, we're going to want to secure as much residual length to the neck bone as possible while still accomplishing our goals. This is to reduce the drawbacks as much as possible. The drawbacks of this fix are that depending on the magnitudes of the changes you make, you're going to get more drift of your viewpoint from your avatar's actual eye position. That's why we want to keep the neck bone as long as possible and as close to a standard rig as possible. But this is considered a rig hack. With that said, let's get started. Actually, before we make our changes, we should disable inherit rotation on the head. So under the armature, click on the head, and under the bone menu here, click to disable inherit rotation. Okay. First, so we can better see what we're doing, we're going to want to get into weight painting mode. So select your armature, and choose pose mode. Then click on your body mesh, and choose weight paint. To make things easier to see, under the shading drop-down options here, let's change the color to vertex. And under the overlay options drop-down here, click here to enable wireframe. Drag the slider all the way to 1. Hold Ctrl and click on the edge of your neck bone to select it. Press R and Y to lock it to the Y axis. We are just doing this to see how the mesh currently deforms the way everything is set up. Rotate the bone around 90 degrees sideways, and look at how your mesh deforms. With this fix, we're trying to make it so that even if the neck goes into a zigzag pose like this, the mesh doesn't look strange. Okay, before we touch anything, let's make a backup of our vertex groups so we can undo this fix later if we decide we want to go back. To do that, under the Data tab of your body mesh, under Vertex Groups, find your neck vertex group. Under the drop-down triangle, choose Copy Vertex Group. Repeat the process for your head. Find the head, click the drop-down, and choose Copy Vertex Group. Okay, now that our original weight paints are safely copied, we can start messing with things. Hold down Ctrl and click on the edge of the head bone so we can see those weights. With the body mesh still selected, click on this little wrench tool to add a modifier. Add the Vertex Weight Mix modifier. Under Vertex Group A, type in Head, and choose your original head vertex group. We're not going to be ever touching the copies that we made, just leave those alone. Under Vertex Group B, type in Neck, and choose your neck. Under Mix Mode, choose Add, and under Mix Set, set it to All, and click Apply. This has copied all of our vertex weights from our neck bone into the head bone. Next, back on the Data tab of your body mesh, find your neck vertex group, and click the little minus sign to delete it. Now click the plus sign to make a new empty vertex group, and double-click on the new group to rename it, and carefully name it exactly the same as your old neck vertex group. I think it's case sensitive, so be careful. Note that using an empty vertex group for your neck might cause Unity to unmap it when you re-import your avatar, so make sure you check in the humanoid rig configuration and remap your neck if that happens. Okay, now we're going to change the length of the neck bone. So with your armature selected, go into Edit mode. Press Alt-A to make sure that everything is deselected, and then press B to open the box selection tool, and carefully select the base of your head and the end of your neck bone. Grab the Move tool and move this joint down. I'd recommend reducing the neck bone to about 3/4 of its original length at first. Remember that our goal is to retain as much length as possible in the neck bone while still attaining our fix. So reducing it to about 3/4, set the armature back into pose mode, left click to select the neck bone, and rotate it into a zigzag position. Hold your middle mouse button to look around your mesh and see if it looks bad. In this case, it still looks a little bit bad on my mesh, so 3/4 length wasn't short enough. Press Ctrl-Z to undo the rotation, and go back into Edit mode. Let's repeat the previous process to shorten it slightly more. Press Alt-A to deselect, press B to make a box select, and select the base of the head and end of the neck bone. Let's try reducing it slightly more. Go back into pose mode, select the neck bone, and press RY to rotate, and look around your mesh to see how the deformation looks. This still looks a little bit strange, but we're getting close. Ctrl-Z to undo, go into Edit mode, Alt-A to deselect, box select the base of the head and the end of the neck, and reduce it slightly more. Back into pose mode, select the neck bone, R and Y to rotate. Let's give it a good zigzag here, and look around our mesh. This doesn't look too bad. So I'd say with this model, this is about the threshold where no matter the neck pose, the mesh doesn't look crazily deformed, but we've still retained as much length as possible to minimize the downsides of the view drift. Press Alt-R to undo the rotation in pose mode. And there we go. We're ready to export the model back into VRChat. I should note that because we changed the position of the head, a couple things might be affected. If you had any game objects in Unity parented to your head, you might need to reposition them. Also, because the game calculates your avatar's arm length as the distance between the root of the head to the root of the wrist, we've slightly changed this distance. This means that the user real height that you calibrated before to perfectly fit your avatar might need to be slightly adjusted. So keep those things in mind when you upload and test out your avatar. Finally, before moving on to the next section, I'll show you how to undo this fix later if you ever want to come back and undo it. With your body mesh selected, under the Data tab, make sure that you still have the neck copy and head copy vertex groups. Then select the modified vertex groups and delete them. So select head and click the minus sign to delete it. Select neck and also click the minus sign to delete it. Next, double-click on your backup copies and rename them to their original names. So double-click on neck copy and rename it to neck. Double-click on head copy and rename it back to head. You will also need to restore the original bone position. You can either approximate the original position or open an old save file and take note of the coordinates at the root of the head. And copy and paste those coordinates back into the root of the head in this save file and the tail of the neck bone. And that should restore your avatar fully to its original state. And that's it for the full walkthrough. But one more thing I want to go over is how you can get help if you need it. The best place is probably to post in the VRChat Discord server in the Avatar Rigging subchannel. But if you post there, you should share screenshots of your rig, and I'm going to show you how to take good screenshots to share there. So in Blender, what you're going to want to do is press numpad 1 to view from the front, and then press Windows Shift S to start taking a screenshot, and then drag to select the area that you want to use for your screenshot. And when you've done this, it's already copied into your clipboard, so just press Ctrl V to paste, and there you go. You should also take another screenshot from the side. If you have an A-posed avatar, then the bones of the arms might be in the way of showing how the spine column looks. So select the center of your body using the Alt-B selection tool, and mask out everything else except for the center. And then press numpad 3 to view from the side, and Windows Shift S to take your screenshot, drag to select. There you go, and in Discord, Ctrl V to paste, and send it. And that's all you need to do. Thanks for watching until the end of the video. If you want to find more of my stuff, you can check the video description for links to my Twitter and also my Discord. Also, check the description for all kinds of useful information. I tried to load it up with stuff for you there. If you found the video itself useful, you could consider helping me out with the algorithm and subscribing. Other than that, good luck with your avatar edits, and take care. See you around!